class, let's try to understand class loader subsystem functionality. What are the different activities class loader will perform? Okay. And then we will see how this bytecode is stored and how the static variables memory allocated and how the object is created, how the methods logic executed. We will see practical. And now let's see now. Okay, observe. JVM starts with the command Java. Once the JVM started, once the Java command you executed, JVM is divided into JVM memory is divided into 5 runtime data areas. So for 15 to 20 minutes, the story will go. Please carefully watch. After 15 minutes, and if you ask me any questions, you don't understand anything, okay? So that's why there is no point of confusing, only point of understanding. That's it, okay? Just listen what I am telling, enough. You will understand everything. Okay, now this is our JVM runtime data areas. Okay, runtime data areas. Now this runtime data areas, nothing but JVM, is divided into 5 runtime data areas. One, method area. Number 2, heap area. Number 3, Java stacks area. Number 4, program counter register area. Number 5, native methods stack area. Right? Chhat Puja is a festival of which state? Bihar. When is that? Today or tomorrow? Tomorrow. If people want holiday tomorrow, today, tomorrow, 2 days. Huh? Three days. Huh? Alok, what is that? I didn't understand. Now no problem of HD crashed. Okay. HDD SSD. What is the meaning of SSD? Okay, now understand story. Please listen. When you run Java command, JVM is started as a process by occupying some memory from RAM. This diagram you also should write after some time. Okay, so that's a please try to listen. Then JVM is searching for class example where in a method area. In a method area, class example is not available. JVM should execute what you call example class. So it is searching for example class in method area. It is not available. Then who is responsible to load class? Who is responsible to load this class into JVM? Class loader. Then JVM requesting class loader to find the example.class file and load into method area. Okay, this is the basic setup is completed. Okay, now listen. Class loader is trying to search for the class. Where this class is available? This class is available in the hard disk, but where? Okay, there are totally 3 places are there where class loader can find the class. Number 1, bootstrap class path. Immediately type, sir, what is bootstrap class path, sir? Type, come on, type. Okay, the moment the word is coming in from my mouth, then immediately what you do? Type, sir, what is bootstrap class path, sir? I don't understand, sir. Type it, Tumri fellows. Next one, extension class path. And third one is application class path. Okay, a class can be available at 3 places, either in bootstrap class path, or in extension class path, or in application class path. Okay, what is the bootstrap class path? Class path is nothing but a folder where classes are available. Now C:/JDK 1.8.0 underscore 271, nothing but version number, you can take anything. Just I am writing 1.8.0 xxx, any version number you can take, slash JRE folder contain lib folder which contain rt.jar comma some other jar files. There are so many jar files are there. Okay, the classes, the predefined classes, all predefined classes which are available in rt.jar. This path is called what? Bootstrap class path. The classes which are used for booting JVM. Okay, if you want to start the JVM, I need so many classes. All the classes are loading from where now? rt.jar file. That rt.jar file path is nothing but bootstrap class path. Booting, that's why it's called bootstrap class path. Okay, next. No, we have a one place where we can place classes common to all projects. Okay, we have one place where we can place the path common to, we can place the classes, jar files and other things common to all classes, okay, all projects. That place is called extension. Okay, extension class path. The extension class path is nothing but C:/JDK 1.8.0 underscore different version numbers, any version number, JRE/lib/ext folder slash. There are so many star.jar files. Okay, many jar files can be there. So what is the difference between lib/rt.jar and lib/ext/jar file? Lib/rt.jar file contains predefined classes which are given by Sun Microsystem for developing our projects. But whereas extension class path contains the jar files, maybe Sun given jar files or our project required jar files, which are common to all projects running in our system. For example, I wanted to, I have 10 projects are running in my system. All 10 projects required, all 10 projects are required, database connecting jar files. Let's say 10 jar files required to connect it to database. Then all 10 jar files copying into every project, it consumes some hard disk space now. So instead of copying the 10 jar files in all 10 projects, we can place these 10 projects in, we can place these 10 jar files in a common folder. That common folder is ext folder, that is extension class path. When you access the class, JVM automatically will go to this extension class path and it can find the classes available there and you can read. Okay. Now, if you wanted to access classes from other folders, you have to set class path variable. But come to extension class path, you no need to set any class path variables. Automatically, it will find the classes available in this ext folder. Next, last class path, application class path, is nothing but the folders which you have placed inside class path equal to current working directory dot semicolon, different folders semicolon, first folder, second folder, third folder, fourth folder, your wish. Any number of folders you can place in class path. So class path configure folders are called application class path, because our application required classes, our project required classes are all placed here. Okay, na? So final conclusion, what you need to understand from here. A class required for our project can be available in 3 different places. These are the 3 different places: Bootstrap class path, extension class path, application class path. Then now, if you want to find the classes from these are different places and load those classes into JVM, below, what we need, this class, this particular class loader must go here and search, must go here, search, must go here and search. Then this class loader, what it did, it has employed its own members. Okay, class loader not doing, it has its own servants. Class loader implicitly uses 3 class loaders. Okay, class loader implicitly uses 3 class loaders. What are the 3 class loaders? To search for the classes in Bootstrap class path, it is using Bootstrap class loader. What is the name of the class loader class? Bootstrap class loader. It is using a class called Bootstrap class loader for finding class and loading the class from the Bootstrap class path. Next, for finding the class and loading class from extension class path, it is using one more class called extension class loader. Next, for searching the classes and loading classes from extension, from application class path, we have another class loader called application class loader. Okay. Today we are going to discuss all these class loaders and their working functionality. Okay, na? Then here one point you need to understand. Application class loader is a subclass of extension class loader. Extension class loader is a subclass of bootstrap class loader. Okay, application class loader, subclass of extension class loader. Extension class loader is a subclass of bootstrap class loader. Okay, then now let's start the story. Hey, अरे यार, that's why I hate these drawings. Happily, if board is there, we could completed this topic by this time already. Yeah, these online classes are too many classes. Okay, then now chalo. So now this is our complete, let me also write this diagram and finish. Let me start once. I am also eagerly waiting for offline classes. Okay. Now all components are ready. Now chalo. 1 minute. Ready. One more arrow mark I need to write. So class load subsystem is responsible for loading classes and unloading classes. Okay. So who is the heart of this entire diagram? Who is the heart? Runtime data areas. JVMA. This complete all these diagram is called JVM Rabai. Okay. This fully is called JVM. In that runtime data is a heart. That's why it's there in the middle. Okay, fine. Chalo. And now first step. First step. We'll do one thing. We'll give step numbers last. Okay. When you run Java example, JVM setup is prepared by as a process by occupying some memory from RAM and divided into 5 runtime data areas. And then JVM searching for the searching for the class bytecode, example class bytecode in the method area. In method area, the given class bytecode is not available, then it is requesting class loader subsystem. It requesting class loader to find and load the class into JVM. Okay, it is requesting JVM to find and load the class into JVM. Then class loader is requesting it's a class. It's a internal class loaders. Class loader send the request to application class loader to find the class. Listen carefully, important statement. Application class loader is now responsible for searching for the class in application class path, but it will not search immediately. It will pass that request to its parent class. Okay, it passes its request to its parent class. This passing is a technically called delegation. It delegates the request to extension class loader. It is asking its parent extension class loader. Class loader is asking me to search for class example. Can you please find you yourself do you have that class in your class path? Then extension class loader is responsible for finding the class in extension class path, but it will not search there. Again, it will delegate the request to bootstrap class loader. Okay, na? Then bootstrap class loader will search for the class in bootstrap class path. In bootstrap class path, the example class obviously not available. Then it will throw an exception to extension class loader. Then extension class loader catch that exception and saying that, okay, bootstrap class loader, no problem. I will search in my class path. It will search in the extension class path. In extension class path, example.class file is not available. Then it will throw exception to application class loader and telling that, sorry, application class loader, the class you have asked is not found in me. Okay, no problem, application class loader. No problem, extension class loader. Application class loader searching for the class in application class path. If application class path also not found the class in its class path, then it will throw an exception to our project. It will throw an exception to our project. The exception is class not found exception or no class def found error. Okay. Now finally it will throw runtime exception, no class def found error or class not found exception it will throw. Okay. If class is found in any one of the class path, if the class is found, then finally the class from either bootstrap class loader or extension class loader or application class loader, the class is loaded into method area. Up to now, all you understand? The class is loaded into method area. Tell me, in method area, the class bytecode must be stored, na? In method area, the class bytecode must be stored. To store the class bytecode in the method area is a memory, na? Let's say this is your classroom. Okay, this is the classroom. and this is my dais. Here I stand here to teach you class. Now all the people are here. All the people are here sitting now. Tell me, this classroom is divided into two parts, right? Boys side and girls side. Then are you sitting there on the floor? No. You will be providing chair, right? Chair 1, chair 2, chair 3. Right then in the chair you are sitting and then listening class. Hello. Now tell me, are you occupying this entire classroom space? No. What are you doing? You are occupying only the space how much your body required. If your body is too much weight, then 2 chairs space you are taking. Correct? So if your body is thin, then you are taking only 1 chair space. So it's depending on your capacity, body capacity, then you are taking the decision. Then now tell me, the class that is loading into JVM, the bytecode must be stored here. To store bytecode inside method area below, like how we are providing the chairs, there should be something called, some memory should be created here. Na? It will not occupy complete memory of method area. How much memory required, that much memory should be occupied, and in that bytecode should be go and store. Na? Then tell me how. Array, inside JVM, anything you wanted to store, it should be either variable memory or it should be object memory. Na? I'm going very slow. Please try to concentrate. Okay. If you want to store any data inside JVM, that should be either variable memory or it should be object memory. If you want to store one value, okay, variable memory. If you want to store multiple values, object memory. Then bytecode is a one value or multiple value. What is a bytecode? Bytecode is an instruction, right? It's an instruction set. One instruction, there are many instructions are there, many instructions. To store many instructions, variable memory required or object memory required? Object memory required. Wonderful. So first you come to a conclusion, we need object memory. Super. Next question. If you want to create object, I need one class now. If you want to create one object, I need one class. Okay. If you want to store, if you want to store student data, you will use the class called what? Student, right? If you want to store employee data, you will use a class called what? Employee. If you want to store bank account, you will use the class called what? Bank account, right? Class student, new student. Class bank employee, new employee. Class bank account, new bank account. Similarly, if you want to store a class bytecode, what is the name of the class? Guess. If you want to store if you want to store if you want to store class bytecode, what is the name of the class? Come on, guess fast. Devesh Pandey, you want to store object information or class information? You want to store object bytecode or class bytecode? Class bytecode. Then what is the name of the class? Class. Capital C class. Capital C class. Okay. So small c class is keyword. Capital C class is class name. Areba, Java is case sensitive. Small c is not equal to capital C. Okay. Capital C class. Then tell me, here who has created this class? I created a? No. It's part of JVM. Okay. Sun Microsystem already created a class called class. Then for loading and storing the class bytecode inside JVM, class loader will create one instance of java.lang. Class instance. It will create one instance from java.lang.class, and then it will store the bytecode instructions. All the bytecode instructions will be stored here. Is everyone understand? Then tell me, if interviewer ask a question, who will store class bytecode inside JVM? Answer is class loader. Okay. Which class loader will store the class bytecode inside JVM? It is depending on the place the class is available. If the class is predefined class, it is loaded and stored by Bootstrap class loader. If it is an extension class path class, then it is loaded by class loader. I mean extension class loader. If it is available in class path configure folders, then application class loader will load the class into JVM. Next, how the class bytecode stored in the JVM? Class bytecode is stored in the JVM by using java.lang.class instance. Class loader subsystem will create java.lang.class java.lang.class instance, and then its bytecode is stored inside JVM. Everyone understand? Then tell me, inside method area, class loader subsystem is creating java.lang.class instance. Listen carefully, very important point. Listen carefully, no, very important. Generally, object we are representing by circle, right? Java.lang.class instance is also object. But to differentiate from regular class objects to java.lang.class object, I myself, it is my design, okay, my diagram, I myself choosing java.lang.class object as a box, not as a, I'm taking as a box, not as a circle. Is it clear? It is my diagram, HK diagram, okay? So generally object is circle only represented, but I am choosing it as a box for differentiating from normal objects, okay? Then tell me, this is what object? So class loader subsystem creates java dot, I'm writing shortcut, java dot lang dot class instance one. As many classes we are loading, those many instances are created, correct? As many student objects you want to store, those many instances we are creating from the student. Same way here, as many classes we are loading, those many instances are created. Now, the complete example class information is stored here, okay? But what am I doing? I am only for understanding purpose, I am writing class name example, okay? Class name example, okay? The class name I am writing here, class name and its members, okay? What are the members available in the class? Yesterday we discussed. Tell me, inside this class, what are the different members available? First, we'll have static variable, static variable, will have what, non-static variable, and will have static block. Tell me, is instance block, okay, instance block is available, but it is a part of constructor, okay? For your understanding, let me write instance block, constructor, static method, non-static method, okay? Static method, non-static method, all these members declarations and their logic will be stored here, okay? Main method also should store, where is the spacer bar? Okay, I will write here, okay? Main method, their declarations, definitions and their logic, everything is stored here. Inner classes are loaded only when you access explicitly. Inner classes are part of separate dot class file. It is not loaded without you loading it. Yeah, give me 1 minute here. Okay. So the entire class byte code is stored here. Did you understand this java.lang.class instance creation? Up to now, okay na? So now, can you please apply the step numbers now? So this is the class loader subsystem functionality, right? How the class loader work. Yesterday I told you class loader working functionality. I will teach you. This is the class loader working functionality. Now let us go for step numbers now, right? Now tell me, step number 1. When I run Java example, JVM is prepared. Then JVM searching for example class in method area not found. Then it is requesting class loader to find and load the class. Class loader is giving the request to application class loader for finding. It is giving request to application class loader for finding the class. Then application class loader delegate request to extension class loader. Delegate request to extension class loader. Extension class loader delegate the request to bootstrap class loader. Bootstrap class loader search for the class in bootstrap class path. Bootstrap class path not found the class, then it throwing exception to what? Extension class loader. Extension class loader search for the class in extension class path. Extension class path will throw the exception to application class loader because the class is not found. Then application class loader search for the class in application class path. If a class is not found, then it will also throw an exception. What is that? No class def found error or class not found exception. Shit. Okay, and next, if class is found, then it will load that class inside JVM by creating java.lang.class instance. It creates java.lang.class instance and store the bytecode inside JVM. So totally how many steps are there? 15 steps are there. Now listen carefully. This entire algorithm, searching the class and loading the class into JVM, this entire algorithm is called as parent algorithm. Okay, if interviewer ask a question, what is the algorithm, what is the class loader algorithm for searching and finding the class and loading the class into JVM, you must answer parent delegation hierarchy algorithm. Ravuji, what algorithm? Parent delegation hierarchy algorithm. What the meaning of parent delegation hierarchy algorithm? When class loader requests the class to load, it is not loading the class into JVM from its respective class path. It is delegating its request to its parent. Okay, it's delegating request to its parent. That's why it is called parent delegation hierarchy algorithm. Then now you must ask me a question. Why it is requesting parent to load the class? Why it is not directly loading the class? Can anybody try to answer? I have the questions now. Question number 1. Why parent delegation hierarchy algorithm is developed? Question number 1. Why parent delegation hierarchy is developed? Why directly not searching for the class and why it is not loading? This is a question number 1. Can anybody think and tell me? Guess and tell me why parent delegation hierarchy algorithm? Now, if you go through once, okay, if application class loader, what do you think? If application class loader directly loading the class from application class path, then what is the problem? There may be one problem. That's why it is not loading from there. What is the problem? Guess. Bhai, if you remember in identified chapter, you have read in material, what is that? We can create our own class. We can create our own class. We can create our own class by using predefined class. For example, I can create my own class with the name string and even with predefined package name. Predefined package name java.lang. For example, if I create my own class with java.lang.string, then when I use the class called java.lang.string, tell me, if application class loader is directly searching for the class in application class path, java.lang.string is loaded from our current directory, and predefined classes are never loaded into JVM. All you understand? Why parent delegation hierarchy algorithm is implemented? Why application class loader directly not loading the class from application class path? If it is loaded from application class path, the problem is predefined classes are never loaded into JVM from our program. If I access any class, any predefined classes, and if that predefined class is already available, with that predefined class, if I create my own class name, then never loaded. In order to load predefined classes, first priority, they have developed this parent delegation hierarchy algorithm. With the parent delegation hierarchy algorithm, because application class path giving request to extension class path, giving request to bootstrap class path, and searching first here, java.clang.string is found in rt.jar file. From there it is directly loading. Then our local classes are never loaded. Then it is a problem now, sir. Who created that problem? You created, you solve it. You change the package name to your own name, p1, p2, so the problem solved. All are catching my point? You created problem, you solve the problem. Okay, up to now all you people understand, got clarity? Why parent delegation hierarchy algorithm? Got clarity? Then next question coming in my mind. Okay, then agreed. So if parent delegation hierarchy algorithm is implemented, okay, agreed, it's a good idea. But then my question is, why they are giving request to application class loader, and why they are moving from application class loader to extension class loader to bootstrap class loader to loading the class? Why this much journey? Let class loader directly give the request to bootstrap class loader, problem solved. Okay, now directly give the request to bootstrap class loader, then problem solved. Listen carefully. If class loader has given request directly to bootstrap class loader, if a class is not found in the bootstrap class path, then next it has to search in extension class path and application class path. Then now the control is coming to class loader, then class loader should call extension class loader, then again control is coming, it should call application class loader. Are you catching my point? So there is so many calls, repeated calls are happening. And moreover, in Java, we can create our own class loader also. Okay, our own class loader, my class loader. I can create my own class loader with the name my class loader. My class loader will become the subclass of class loader. Okay, subclassing from class loader, we can create my own class loader. If a class loader subsystem is having all the calls to the respective classes, it is a predefined class. How it can have the call to our class loader? Is my question understand? How my class loader will have the call to, how the class loader can call the method of our class loader? It's not possible. Okay, so class loader, if it is calling directly the parent class bootstrap class loader, we cannot, I mean, further searching cannot be done in other class path. So that's why they have developed parent delegation hierarchy algorithm. Request is giving to application class path or custom class loader. From custom class loader, you go to application class loader. It will become implicit, automated. If class loader is making a call to bootstrap class loader, it become manual work. If it is making class loader to application class loader, it become what? Automated work. Okay, as many further subclasses are coming, no problem. Automatically implicit calls will be happen. So that's why parent delegation hierarchy algorithm is implemented. So I'm giving again 2 points, 2 questions again repeating. Question number 1, why parent delegation hierarchy algorithm? Why the class is not directly loading from the application class directly from application class path? Okay, if directly class is loading from application class path, the problem is predefined classes are never loaded into JVM because we can create our class with the predefined class name with package name. Second point, then why directly request is not giving to a bootstrap class path for if you want to load the class first predefined class path? Okay, if the class loader is directly calling bootstrap class loader, it will become manual work, because from the parent class to child class calling will not be happen. From the child class to parent class, from the parent to again coming to child, the calling will be done and it will become automated way. Okay, so this is the basic idea about parent delegation hierarchy algorithm, how the class loader implicitly working. Can I hope all you people got clarity on these points? All you people comfortable? Now can you answer all these points clearly to the interviewer? If interviewer raise a question, tell something about class loader, can you answer all these points now clearly? Okay, what are the responsibilities of the class loader? Now you told how class loader working, okay? What are the responsibilities of the class loader? Class loader is responsible for three things. Okay, class loader is responsible for three things. Number one, it's not only responsible for loading, it is responsible for loading, linking. It is responsible for loading, linking, and initializing. Are you catching my point? Loading, linking. Now repeating once again, what are the responsibilities of class loader? Class loader is responsible for performing three operations: loading, linking, and initializing. For loading purpose, it is using how many class loaders? It is using three class loaders. What are the three class loaders? Bootstrap class loader, extension class loader, application class loader. I hope you got clarity on this point, okay? You got clarity on this point. I no need to explain much on this point, right? You got much clarity on this point. And now the question, try to answer. Class loader is not only responsible for loading the class, it is also responsible for making the class ready to execute by JVM. Repeating again, class loader is not only responsible for just loading the class, it is also responsible for making that class ready to execute. For example, tell me, my administrator is not only responsible for just starting my class, okay, not just announcing the class. Okay, new batch is starting from 26th of November, okay. From 26th of November, morning 7 a.m., I am starting the new batch. Just announcing the date, is it sufficient? No. Just announcing the date is not sufficient. He should also do the promotions now. He should do marketing now. Okay, Argishna is starting the batch so and so date on so and so time. Okay, please inform. He is to do marketing. That means he has to make sure the batch is get successful, right? The good number of strength is coming to the class. It is the responsibility of the administrator only. Is it clear? Loading the class into JVM is not sufficient. Class loader is responsible for making this class executable by this runtime system. Are you catching my point? Then tell me, how class loader will make this class executable by this runtime system? First, it will verify the loaded class bytecode valid or not. Okay, for verifying the loaded class valid or not, several test cases are there. First one, is this class contain any superclass? If the class is a subclass of superclass, is that superclass available or not? If superclass is available, in that superclass, constructor available or not? In superclass, is there any method overriding in the subclass? If overriding, all the rules are followed or not? Is there any final method overriding or not? Is there any malicious code is available or not? So there are several test cases are there. All these test cases it is verifying. If all test cases are passed, then it is ready to execute. So what are the phases class loader is doing? Number one, loading. Number two, linking. In the linking phase, it is performing totally three activities again. What is that? Number one, verify. In a linking phase, it has three activities: verify, and then following by prepare. In a verification phase, it is performing several test cases. After all verification completed, it prepare. Prepare means what? Allocating memory. tell me, if you wanted to run your class logic execution start from where now? Main method. If you want to start main method execution, first of all, static variable memory should be allocated and static block logic should execute. Are you catching my point? Static variable, static block logic execution completed, then only main method is ready to execute. So class loader subsystem is responsible for performing totally how many activities, Baba? How many activities? 3 activities. Number 1, loading. Loading is nothing but finding the class and storing its bytecode inside JVM. And the next inner and the next linking. Second activity is what? Linking. In the linking phase, it is responsible to perform 3 activities. What the 3 activities? Verify, and then prepare, and then resolve. Okay. Verify phase. In verify phase, it is verifying the loaded bytecode is valid or not. If loaded bytecode is valid, then successfully it is going for prepare phase for execution. In prepare phase, it allocate memory for static variables with a default value. Okay. And then next resolve phase. This resolve phase I'll explain later. I'm just ignoring it. After this linking phase is completed, then it is going to the next phase called initialize. Are Baba, after static variables memory allocated, this default values must be removed with the given values na. Okay, you have to initialize, right? Who will initialize the static variables? Static block. In the initialization phase, static block is executed and static variables are initialized with the given values. So finally tell me, after this JVM setup is completed and class loaded by inside JVM by creating java.lang class instance, then next class loader is continuing 16th step. What is doing? It allocates memory for static variable. Okay, it allocates memory for static variable first with what value? It allocates memory for static variable with what value? Come on. First with the default value based on data type. If the variable is int type, default value 0. If a variable is a double type, default value is 0.0. If the variable is of type if the variable is of type char, okay, or boolean false, like that, based on data type, default value will be stored. And then next, okay, prepare phase completed, loading phase completed, linking phase completed, and next what? Initialization phase. In initialization phase, it should execute static block na. Hello, where the static block logic is executed, logic is stored in method area, but static block logic is loaded and executed in Java stacks area, right? Logic is loaded and executed in Java stacks area. In Java stacks area, now static block logic is loaded. What the logic of the static block? Just initializing static variables only, na? Right? It contains the logic. Static variables initialization logic is available according to static variables initialization logic. Now inside this static variable, default values are replaced with what value, Bujay? Given values. From the static block logic, then given values are stored here. All are you following? Up to now, all you understand? We have to implement all these points in regular program, everyday program. We have to implement all these points. From the static block, the given values are stored here. Yesterday given theory, today I am giving complete practicals. Okay. Next what? Tell me now. After this, static variable memory allocated, static block execution completed. Next what? Now this class is ready to execute na? This class is ready to execute. Then tell me, who is ready to execute? Who will execute this class? Who will execute this class? Class is executed by execution engine. Now class loader subsystem will hand over control to execution engine. Now execution engine come into picture. Now it is running the class execution. Starts with what? Main method. So main method came into picture. Inside main method, whatever the logic you have written, that logic will start execute. Assume that main method, tell me, main method has a parameter, na? Not assuming, okay? Main method has a parameter. What the parameter name? Args. So args variable memory allocated here, right? But args variable is a string array. It is a primitive type or reference type? Reference type. It required object. Who will create the object for this parameter? JVM. Okay, JVM background creates one empty array object. JVM background creates one empty array object. Okay, JVM creates one empty array object. String array object. Empty string array object is created. Empty string array object created with reference what? 10, 10, let's say. 10, 10 or 1, 1 or whatever. Tell me, this java.lang.string array is java.lang class array class is also object, na? It also contain its own reference assuming as 1, 1, 1. It is 10, 10, 10. Now the 10, 10 will be stored here in the args variable and pointing to it. Sir, am I confusing by talking all details in a single day? All are you comfortable? All are you understanding? By talking all these points in single day, am I confusing you? Please try to improve your understanding capacity. Point into this one, okay? The next point, tell me now. After string array object is created, then next assume that in main method I have local variable. I have one local variable, let's say p variable is there. Assume one primitive variable, p variable, local variable is there. Then p variable memory is created inside. P variable memory created here, local variable memory created in with any given value? No. Any default value? No. Directly given value. Directly with given value will be stored. No default value in the local variables, already you know it. Now assume that this loaded class example class object created. Example E1 equal new example. Then tell me, E1 variable memory allocated here because E1 is created inside method. It become local variable. Hello. Now tell me. Now this E1 variable memory created. Below now E1 variable memory after creation, its object should be created. Na? Where object is created? In heap area. In heap area, example class object is created. In heap area, example class object is created with the non-static variables. In heap area, example class object is created with non-static variables. Currently, who is working? Class loader or execution engine? Class loader or execution engine? Execution engine, right? Not class loader. Class loader jamana over. Now execution engine doing all this work. Non-static variable memory created with base address 3030 or 2020. Okay, 2020 and first with what values it will store? Default values. Yes or no? First non-static variables are created with the default values. Variable chapter. If you forgot, that is your headache, not my headache. Okay. You must remember every chapter point every day I am using in next chapters. And then who will initialize this object? Initializing this object by constructor. Okay, I will tell that constructor job everything later. Let me directly write given value. Okay, unnecessary more if I include, you will confuse. Okay, right, given value will be stored here. Then finally, the reference is stored in E2 variable, I mean E1 variable and pointing to it. So after the story completed, I will give one program. You have to draw JVM architecture. For that program, you have to draw JVM architecture. Okay. Everybody, all people understand up to now? So finally, tell me where class bytecode is stored? In method area. Where class bytecode is stored? In method area. Next, where Static variable memory created in method area, where um, where what you call a class object is created, where class object is created in heap area. Next, where local logic is executed in Java stacks area in main thread, where objects are created in heap area, where parameter local variables are created in Java stacks area. So this clarity you need. Next question. Who will load class into JVM? Class loader. Who will allocate memory for static variable? Class loader. Who will execute static block, initialize static variable? Class loader. Who will execute main method? Class loader? No. Execution engine. Who will create object? Execution engine. Who will destroy object? After object usage completed, who will destroy that object? Execution engine with the help of garbage collector. Okay, with the help of garbage collector, execution engine will destroy that object from the heap area. That's it. Does everyone understand, I hope? If you have any questions, please ask. Don't ask confirmation points, okay? Okay? Yeah, Devesh Pandey, class instance also created in heap area only. For understanding, I told you now I'm creating in method area. Class instance created in heap area and its reference is available in method area. Okay? Okay. Now let's start. Let's complete the remaining part of this diagram. Tell me now. Like main thread, can we have more threads? Like main thread, I am ignoring some of you are asking questions that will come in the next slide. Okay. I am asking up to now what I explained. Do you have any questions? But you are asking questions of next slides. That's why I am ignoring it. Okay, now I am ignoring your questions because you are asking next slide. Now I told you up to now you have any questions. Now tell me. Using multi-threading chapter, I can create my own new threads. Okay, thread 0, thread 0, thread 1. Yesterday I told you thread 0, thread 1. Like this I can create n number of threads. Your wish. You can create n number of threads. As and when you create a new thread, inside program counter register, okay, now you are going to create, implicitly JVM create program counter register for first, second thread, program counter register for third thread. Okay, now like this, as many threads you create, those many program counter registers will be created here. Next important point. As and when you create one new thread, for executing the native methods of these threads, here native stack is created. Native stack created for second thread, native stack is created for a third thread. Like this, n number of native stacks you can create here based on your number of requirements. Not you created, it is automatically created by JVM background. Okay, now so now tell me, this is thread hyphen 0, this is thread hyphen 0, and this is thread hyphen 1. Okay, and this is thread hyphen 0 PCR, and this is thread hyphen 1 PCR, and this is thread hyphen 0 native stack, and this is thread hyphen 1 native stack. Okay, so this is your complete JVM. Now the question, I forgot to ask you one question. Let me write. If the class is available, let's say example dot class, okay, let's say a dot class is available in what you call bootstrap class path. Let me take predefined class. Okay, string dot class file is available in bootstrap class path, also available in extension class path, also available in application class path. Then the class is loaded from where? Bootstrap class path according to parent delegation hierarchy algorithm. Na, it will load only from here. Is removed and we got a special name for it. What I should take here? Okay, it got, this extension class loader got one special name. Okay, the name is platform class loader. What is the name of the class? Platform class loader. The name of the class loader is platform class loader. Earlier, the name of the class is extension class loader. Now the extension class loader name is removed, and in place of extension class loader, what the name came into picture? Platform class loader. Okay, so platform class loader will load the class into JVM. Okay, everyone got clarity? Yeah? So these are the changes has got in which version? Java 9 version onwards. From Java 9 version onwards, these are the changes we got. Can hope all people understood? Up to Java 8 version, no changes. From Java 9 version onwards, these are the changes we got. So this is the complete knowledge about JVM architecture, full story. So can I hope all the people got clarity? Open material. In material, all these points are clearly there, check. Yeah, application class path one. Open material. Yesterday we completed up to this page and I given up to here explanation. Now today class, explanation on class loader subsystem. Class loader is a class, it is responsible for performing below 3 activities: load, link and initialize the given class code. Below diagram will give you outlook of class loader subsystem. The class loader performing 3 activities: loading by using these 3 class loaders, and linking with the 3 phases: verify, prepare and resolve, and finally initializing. In class loading phase, class loader will load and store the given class bytecode into JVM's method area. Class loader subsystem contains 3 types of class loaders for loading core Java API classes and user defined classes. They are bootstrap class loader or pre-module class loader, extension class loader, application class loader or system class loader. Next, bootstrap class loader, it is responsible for load Java library classes from bootstrap class path. From JDK, from the bootstrap class path, that is JDK JRE lib rt.jar file. It is a part of Java virtual machine implementation. Bootstrap class loader is part of virtual machine implementation. It is implemented in virtual machine means what? It's a part of C and C++. It is implemented in native API, so it doesn't have class name. Remaining all classes remaining class loader contain the name of the class, but bootstrap class loader doesn't contain name. So if you try to display its name, null will be displayed. Okay, listen carefully. Every class is background associated with one class loader. Observe important point. Every class loader, okay? I mean every class. This class is loaded by which class loader? Class loader is also class. One object is created for class loader. That class loader instance is associated with this class. We can get this class is loaded by using which class loader? That class loader name we can retrieve. How can I retrieve? I'll show you the program, okay? I'll show you the program now. Now look at here. So if you try to display the class name, okay, null will be displayed because there is no name of the class. Next, extension class loader. It is responsible to load user defined classes or Java library classes from extension class path, that is from JDK GRE lib ext folder. It is a part of Java API implementation. This code, this class loader is implemented in Java with the class name ext class loader. Observe, we have taken class name as extension class loader. We pronounce it as an extension class loader, but the name of the class is only shortcut ext class loader. Next, this class is defined as inner class in the class called launcher. Okay, which version topic I'm trying to explain now? 1.8 version. What are the changes in 1.8? We have, what are the changes in Java 9? I will explain you. The package name is sun.misc.launcher. So when we try to display its name, it is displayed as sun.misc.launcher $class loader. Okay, so inner classes are represented with a $. Next, application class loader. It is responsible to load user defined classes from application class path. It will load classes from current working directory or from the folders configured in class path environment variable. This class loader is also implemented in Java with the class name app class loader. So we are calling the class name as application class loader. We are calling the class name as application class loader, but the shortcut name is what? App class loader. The name of the class is app class loader. It is also inner class of sun.misc.launcher class. Okay, right? If you try to display its name, it is displayed as sun.misc.launcher $app class loader. So this is the basic theory point about each class loader given clearly here. Then class loader working functionality. Class loader will work on parent delegation hierarchy algorithm. When class loader get request to load a class, it will first delegate this class loading request to its parent. The parent class loader in the turn delegates this request to its parent. The chain of the delegation continues through to the bootstrap class loader. In this chain of hierarchy, the bootstrap class loader is at the top. When JVM come across a type, it checks for that class bytecode in the method area. If it is already loaded, it makes use of loaded class bytecode type. If the class is not yet loaded, JVM requests class loader subsystem to load this class. Okay, all these points, can you please read by your own? Right? So I hope I no need to read again all these points for you, right? I hope you know English how to read. You can read all the 12 points, all 12 points, all 12 points. Look at the diagram, same diagram I given. Clear diagram I given. What are the changes we got in Java 8 version, Java 9 version? Extension class loader, extension class is not there. Extension class path is merged into application class path. Extension class loader name is changed to platform class loader, right? So these are the changes we got. Okay, and now very, very important point. When application class loader get chance to load the class and execute, if application class loader will load class only if class is not found by bootstrap and extension class loaders. Okay, the next important point. If the given class is found in extension directory and also in the local directory, from which directory this class is loaded and by which class loader? Class is loaded by extension directory by extension class loader. As per parent delegation hierarchy algorithm, the extension class path will give the first priority. Then if the class is found in both extension folder and current working directory, this class will load from extension folder by extension class loader. So you can test this program by your own. Okay, you can test this program by your own by following. This is 1.8 version. Okay, this path, this flow, this process you have to follow 1.8 version. In Java 9 version, you cannot work with extension class loader, right? Because extension class path is not there. You try this diagram, this process by your own in Java 8 version. If Java 8 version, if you don't have, you can ignore it. Just you work with the Java 9 version. Okay, then you will get here null. Predefined class, you will get a null here, and here you can get application class loader. Here also you will get application class loader. Is it clear? The next, class lifetime, loading, linking and initializing. In this section, we will discuss the lifetime of a type, class or interface from its initial entry into the virtual machine to its ultimate exit. Every class extension execution will contain below lifecycle phases: loading, linking, initializing, execution, instantiation, garbage collection, finalization, and unloading. These are the 8 phases will be there. Okay, what is happening in loading phase, what is happening in linking phase? Okay, clearly documentation are given. Whatever the theory points I explained, just I have mentioned. This is the diagram. First, loading by 3 class loaders. Linking. In the linking phase, we have verify, prepare, and initialize. In prepare phase, what is doing? Allocating memory for the static variables with the default values. In the initialization phase, what is happening? Static block is executed and static variables are initialized with the given values. Those points I have mentioned here clearly, step by step I have mentioned here. Whatever points I have explained, every point I just mentioned here, you need to read and by heart. Then explanation on runtime data areas. Okay, method area, heap area, Java stacks area, program counter, register area, native method stack area, class loader subsystem, programming element, class loader subsystem task completed. Then explanation of runtime data area, second JVM component. All these runtime data areas clearly given about method area and heap area, all points. Okay, you have to remember, you have to by heart and remember. Classes loaded here and objects are created here. Okay, then both method area and heap area are shareable memory areas to all the threads. Method area and heap area are created on virtual machine startup. Okay, then remaining points you read. Look at here, whatever the diagram I have explained. Next, further steps: after class loading, static variable memory allocation, objects creation, and here static block main method execution. Okay, I have given clearly here. Look at there. Learning JVM architecture theory points is not enough. Let us try to understand all above points practically with a program execution with all 4 types of variables and their memory distribution done inside runtime data areas. I created a class called example with a 2 variables, static variable, 2 non-static variable, main method, 2 local variables, and 2 objects. Then how the memory distribution is done, clearly I have given, already explained. Only thing you need to just go through once this diagram. And I given each and every step here with respect to your diagram. Every point clearly step by step I have given. You have to spend the time. You have 24 hours of the time. In this 24 hours, these 4 or 5 pages you have to read. I know you don't have time perfectly. Compulsory, 100% I guarantee you don't have time to read all these points. Okay. So if you complete up to page number, what the page number 16, up to page number 16, if you read all points and practice and come, next classes about Java stacks area. Tomorrow I will explain about Java stacks area, and tomorrow we are completing the JVM architecture chapter completely. Remaining pages I will explain in tomorrow class. Is it clear to all? So I'm expecting all the people practice and come. Every point is there in the material. Okay, so tomorrow we'll finish JVM architecture, remaining pending topic. Thank you. That's all for the day. See you all tomorrow. Bye bye.